Hey everyone, today we'll be going over LeetCode problem 53, maximum subarray. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given an integer array called nums, and what we want to do is find the subarray with the largest sum and return this sum. We have an example here which I have redrawn on the right, and we see that we have an input which is a nums array, and the output is 6. And this is because the maximum subarray is obtained when summing the 4 with the -1, the 2, and the 1. So this entire subarray, which has to be continuous, makes a sum of 6. The brute force approach for this problem would be to find every possible subarray in this nums array and check to see which subarray has the largest sum. In order to do this, we would have to find first every subarray which starts with the -2. So we'd have the -2 itself, -2 and 1, -2, 1, and -3, -2, 1, -3, and 4, and the same for every number up until reaching the end. Then we would continue on and find every subarray starting with the 1. So we'd have the 1 itself, 1, -3, 1, -3, and 4, and the same thing for every other number until reaching the end. Now, in order to achieve this, as we could see from the code below, we would need two for loops. These are two nested for loops, and because of this, we would have an O of n squared time complexity. And during these loops, what we are doing is keeping track of a current sum and seeing if this beats our max sum. However, we can optimize this approach to become a linear time complexity algorithm. In order to optimize our solution, what we need to do is realize that negative subarrays do not actually contribute much to our solution. So we can actually keep a singular for loop, and for each number, what we will do is increment our current sum, check to see if we've beat our max sum, and third, if our current sum of the current subarray is negative, we can just reset to 0. I'll show you what I mean by this. So when we start off, we have a current sum of 0. However, the first number in our array is -2, so our current sum quickly becomes -2. What we're going to do after incrementing our current sum is check to see if this current sum beats our max sum. Our max sum was initially set to -infinity, so we have beat that. Our max sum is now -2. However, we see that in our third step of our for loop, we want to reset if our current sum is negative. And what this means is that we do not want to consider any subarray starting from the -2 from this point on. We can make our current sum 0 again, and adding the 1, our current sum will become 1. This is because the -2, which we previously encountered, will not give any positive contributions to our growing subarray, so we do not want to consider it any longer. In fact, if we kept the -2 in consideration, our current sum with the 1 would be -1. However, without the -2, our current sum, as we see, is 1. We check to see if the current sum beats our max sum, and it does again, so our max sum now becomes 1. And then we continue on adding the -3 to our current sum, making it -2. This current sum does not beat our max sum, and furthermore it's negative, so we want to restart again, making our current sum 0. And adding the 4, it becomes 4. This beats our max sum, which becomes 4. And then we go and add the -1, making it our current sum 3. This does not beat our max sum, and we go and add the 2, making our current sum 5. This current sum again is not negative, but it does beat our max sum, so we replace our max sum with 5. We then add the 1, making our current sum 6, and we see this beats our max sum, which becomes 6. We then add -5, which makes our current sum 1. Now, even though this number, -5, is negative, our current sum remains positive, so we do not want to reset our subarray. 1 does not beat the 6, however, we add the 4, making our current sum 5, and again, 5 does not beat the 6. So what we want to do at the end is return 6 as our output. We see that this algorithm is linear in time complexity, and this is because we only traverse the array once, And furthermore, it is constant in space complexity because we do not use any additional data structures to store information. We're going to start off our algorithm by initializing our max sum equal to the first number in our array. We could also initialize this to negative infinity if we wanted to. We're going to also set our current sum initially equal to 0, and then start iterating through our array. For each number in the array, what we want to do is increment our current sum by the number, and check to see if we've beat our max sum. Finally, what we want to do is check to see if our current sum is negative. And in that case, we would want to reset our current sum. When we're done with the for loop, we want to return the max sum we found. Let's make sure this runs. And we see that it works efficiently. Thank you very much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.